While the world obsesses over Russia's military hardware and space achievements, something far more revolutionary has been unfolding behind closed doors. Something that could flip the entire aviation industry on its head. The GTD-110M isn't just another industrial turbine. It's Russia's calculated chess move in a game the West didn't even know was being played. What makes this engine so dangerous? How is it threatening to rewrite the rules of modern aviation? Buckle up, because what you're about to discover will blow your mind. Let's rewind to 2022. Russia launches its military operation in Ukraine, and within weeks, the guillotine drops. Sanctions slam down like a steel door. Western giants like Siemens, General Electric, and Alstom pack up and leave overnight. For decades, Russia's entire energy infrastructure ran on Western turbines. Suddenly, those turbines had no spare parts, no maintenance, no future. Power plants across the country faced catastrophic failure. Millions of homes risked going dark. The crisis wasn't just economic, it was existential. Russia stood at a crossroads, collapse into dependency or fight back with innovation. They chose the latter, but not the kind of war you're thinking of. This was a battle of engineering, of industrial willpower, of technological defiance that would reshape their entire future. Fast forward to 2024. President Vladimir Putin appears on screens across Russia, virtually presiding over a ceremony at the Uyaz power plant in southern Russia. A massive turbine roars to life, and Putin's words cut through the noise. The fact that we have new production facilities and that we are becoming independent, technologically sovereign, at least in this segment, is very important. The GTD-110M had arrived, and everything was about to change. But here's where it gets absolutely insane. Hidden within this industrial beast are secrets that could revolutionize aviation as we know it. Aerospace engineers across Russia aren't just interested in this turbine, they're obsessed with it. The reason? The GTD-110M might be the key to unlocking Russia's next-generation jet engines. Let's break down what makes this machine a game-changer. And trust me, each revelation is more shocking than the last. The sheer power output is staggering. This single turbine generates enough electricity to power tens of thousands of homes simultaneously. At the Uyaz power plant, it catapulted total capacity from 454 megawatts to a mind-blowing 560 megawatts. One machine delivering 106 megawatts of additional power, enough to supply 10% of the electricity demand for the entire Krasnodar region. We're talking about a single piece of equipment sustaining cities, factories, entire economies. But power alone doesn't tell the whole story. What's truly mind-bending is how Russian engineers achieved this. Remember those Western turbines Russia depended on? Massive, heavy, requiring complex infrastructure? The GTD-110M flips that equation entirely. It's smaller and lighter, yet somehow more powerful. This defies conventional engineering wisdom, where more power typically means more mass and more space. Think about the strategic implications. Smaller size equals easier transportation across Russia's vast distances. Lighter weight means simpler installation into existing power grids. Compact design translates to lower construction costs and faster deployment timelines. But Russian engineers didn't just match Western performance in a smaller package, they exceeded it. Independent assessments suggest the GTD-110M outperforms comparable Western turbines in several key metrics. Now let's talk efficiency, because this is where things get terrifying for Western competitors. In turbine design, every percentage point of efficiency gained represents millions of dollars saved over the machine's operational lifetime. The GTD-110M was engineered from the ground up to extract maximum energy from every molecule of fuel. Advanced combustion chamber design, optimized blade geometry, cutting-edge thermodynamics working in perfect harmony. Less fuel consumed, more electricity produced. This efficiency breakthrough has massive implications beyond economics. In an era of climate consciousness and environmental regulations, a highly efficient turbine positions Russia as a leader in sustainable energy technology. The turbine proves Russia can compete not just on raw power, but on sophistication and future-forward thinking. But efficiency means nothing if the machine can't survive real-world conditions. Rostec engineers developed revolutionary materials capable of withstanding temperatures and pressures that would obliterate conventional components. We're talking about alloys and composite materials that remain stable under conditions that push the absolute limits of physics. high-temperature resilience, extreme pressure tolerance, corrosion resistance engineered to military-grade specifications. This durability delivers strategic advantages. Reduced maintenance requirements mean lower operational costs and higher reliability. Power plants can run longer between service intervals. Downtime drops dramatically. Total cost of ownership plummets compared to Western alternatives. For a country under sanctions, building equipment that rarely needs replacement parts isn't just smart engineering, it's survival strategy. And here's the kicker that makes Western defense analysts lose sleep. Every single component is 100% made in Russia, not assembled in Russia with imported parts or based on licensed foreign technology. Designed, engineered, manufactured, and tested entirely within Russian borders. From the initial CAD files to the final bolt, it's all domestic. This represents complete supply chain independence, something very few nations can claim for technology this advanced. For Russia, this achievement transcends national pride. It's a shield against future sanctions and proof that technological isolation can be overcome through determination and investment. It's a message to the world that cutting them off doesn't stop innovation. Now brace yourself, because we're about to reveal why this industrial turbine has aerospace engineers absolutely buzzing with excitement. The connection between the GTD-110M and aviation isn't obvious at first glance. One is a massive stationary power generator, the other involves high-speed flight at 40,000 feet. What could they possibly have in common? Everything. Modern jet engines face three fundamental challenges. They must be lightweight to maximize fuel efficiency and payload capacity, they must operate reliably under extreme conditions, and they must extract maximum thrust from minimum fuel. Sound familiar? Those are exactly the problems the GTD-110M was designed to solve. Let's start with weight. Aviation is a ruthless game where every kilogram of engine weight reduces either payload capacity or range. The GTD-110M's compact, lightweight design philosophy directly translates to aircraft engine development. Russian engineers have demonstrated they can achieve superior power-to-weight ratios, the exact metric that determines jet engine competitiveness. Next, consider operational resilience. Aircraft engines endure hell. Takeoff thrust generates internal temperatures exceeding 2,500 degrees Celsius, high-altitude cruising subjects components to extreme thermal cycling. The materials, science, and engineering solutions developed for the GTD-110M, specifically its heat-resistant alloys and pressure-tolerant designs, are directly applicable to jet engine construction. If these materials can handle the sustained abuse of industrial power generation, they can absolutely handle the demands of aviation. Then there's fuel efficiency, perhaps the most critical factor in modern aviation economics. Airlines live and die by fuel costs. Every improvement in engine efficiency directly impacts profitability and environmental footprint. The combustion optimization and thermodynamic efficiency techniques perfected in the GTD-110M provide a roadmap for next-generation aircraft engines that burn less fuel while generating more thrust. But here's what makes this truly explosive. Russia is desperately trying to rebuild its civil aviation industry without Western technology. International sanctions have cut off access to engines from companies like Pratt & Whitney, Rolls-Royce, and CFM International. Russia's domestic aircraft like the MC-21 need competitive, reliable, domestically produced engines. The GTD-110M serves as a technology demonstrator, a proving ground for innovations that will power Russian aircraft for decades to come. The research and development breakthroughs from this project create a knowledge base that didn't exist before. Engineers now understand advanced materials at a deeper level. Manufacturing processes have been refined and perfected. Quality control standards have been elevated to world-class levels. All of this intellectual capital feeds directly into aviation turbine development. Of course, you can't just bolt a power plant turbine onto an aircraft wing. The engineering challenges are immense. Aircraft engines require dramatically different thrust profiles, weight constraints, and aerodynamic considerations. But the fundamental technologies and core innovations translate directly. Heat-resistant materials work the same whether in a stationary turbine or a jet engine. Aerodynamic blade design principles apply universally. Russia's path to this achievement was anything but smooth. In 2017, disaster struck during initial prototype testing. A turbine exploded spectacularly, a catastrophic failure that could have killed the entire program. Engineers returned to drawing boards, redesigned components, strengthened materials, refined manufacturing processes. Each failure became a brutal lesson in the unforgiving nature of advanced turbine engineering. Building large gas turbines represents one of humanity's most complex engineering challenges. Tolerances must be measured in micrometers. Materials must perform flawlessly across extreme temperature ranges. Thousands of components must work in perfect synchronization at rotational speeds that generate forces capable of tearing metal apart. Russia absorbed these lessons and pushed forward. The GTD-110M's success proves their engineers didn't just recover from failure, they learned from it and ultimately triumphed. But success in the laboratory is different from success in the marketplace. Rostec plans to produce at least 4 turbines annually, a target that demands massive infrastructure investment. Factories must be built or upgraded. Advanced manufacturing equipment must be acquired or developed domestically. Quality control becomes exponentially more challenging at scale. Prototype success doesn't guarantee production consistency. International isolation presents another major hurdle. Russia's exclusion from global supply chains means no access to certain specialized materials or components that Western manufacturers source internationally. Everything must be developed domestically, from sophisticated electronic control systems to exotic metal alloys. This slows innovation cycles and increases development costs, but it also forces technological self-sufficiency that builds capabilities immune to sanctions. In aviation, if GTD-110M technologies successfully transfer to jet engines, Russia breaks free from one of the West's most powerful leverage points. Currently, Western engine manufacturers hold enormous power over global aviation because no viable alternatives exist for most applications. A competitive Russian engine option changes that equation entirely, offering airlines and aircraft manufacturers genuine choice. The GTD-110M proves that technological advancement doesn't require integration into Western-dominated systems. It demonstrates that sanctions intended to cripple innovation can instead ignite it. Russia has sent a message that resonates far beyond turbine specifications. Isolation cannot stop determined innovation. The game has changed, and aviation will never be the same. Can the GTD-110M truly compete with Western technology? Drop your thoughts in the comments below, and don't forget to subscribe for more shocking tech revelations.